My people, the Science Genie again here. In this video, we are going to be covering the structural formula versus the condensed structural formula. So with the structural formula tells us the types of atoms that we have and how many of those, showing all bonds. Just like here you can see that we have all these bonds here, bond here, bond here, bond there, like that, guys. So now the condensed structural formula now does not show all the bonds. So basically it means that some of the bonds are hidden, but the structure of the molecule or the particular arrangement is not changed. So it means, like, if you can see right here, now this first carbon over here, it is having how many hydrogens? One, two, three hydrogens. And this carbon here has three hydrogens. So now we go to the second one. The second carbon has two hydrogens, and then now here's the second carbon connected to that one having two, so on, just like this, having two hydrogens, and the last one having three hydrogens over there. So now, as I said, it does not show all the bonds. So now this second one right here, it is still a condensed structural formula, but we would say it is a semi-condensed structural formula, whereby now this guy does not show all the bonds, but it shows some of them. Just like here, it is showing some of the bonds, not all the bonds are indicated, right? So now there is another way that you can draw the structure, right? So this condensed structural formula can be represented in such a way. So what does this mean here? So let us start with this. Let us understand this part first. So this part, we have this guy over here that is a carbon with three hydrogens. We have this guy over here, which is a carbon with three hydrogens. And then now we have this guy. We have this guy in the middle here, which is this guy that has a CH2, and there is this N underneath here. What is this N? This N will tell us how many times that unit will repeat. So if we have CH2, that CH2 unit, how many times will it repeat in the chain? So as you see that in this first guy, we have this CH2 unit, we have this CH2 unit, so we are having two of them. So you can just have your CH3, your two CH2 units that are repeating, and then you can have your last CH3 unit over there. So I hope people understand. Let us move on to the other type of example. So now this example here for an alkene, you see that there's a double bond over here, and then we have other bonds being shown in their specific arrangements. And then now we can see right here that this molecule, in the first carbon over here, we have a carbon with two hydrogens, so it's a carbon with two hydrogens. And then this second one here, because of the bonds, it has one hydrogen, because now you have to remember that for your carbon you have to have four bonds around it. So the second carbon has one, two, three, and four bonds around it, so it can only have one hydrogen. So that is why we say it is CH. And then you have your CH2 units that are here, so it's a CH2, and the last one, which is your CH3. So the trick to this, basically, when you are given a condensed structural formula and you are supposed to draw your structural formula, you look at your carbons. There will be some cases that we will cover whereby now a molecule is a bit complex, where they give you the structure but it's a bit complicated. It is not an issue. But for now, since we're dealing with this one, simple as it is, so now you are going to start with your carbon atoms. You are going to count how many carbon atoms you are going to have, right? So now we see that in this guy over here, we have how many carbon atoms? One, two, three, four, five. So we have five carbon atoms. So that's what you're just going to do. You're just going to say 1, 2, 3, 4, 5. And then the best place to start is at your CH3 part. So we're gonna start with our CH3. You're gonna start with your CH3 part over there, and then you're gonna follow with your CH2, guys. So you're gonna put your CH2s just like this. It's CH2, and then you are going to put this guy here. It is CH, and then the last one has CH2. And then now, when you are done drawing the structure, you are going to count your number of bonds. So we see that this first carbon has 4 bonds around, this one has 4 bonds, this has 4 bonds, this one has 3. So now, since this one has 3, where can we put the other bond with it? So can we put the bond here? No, because this bond will make this carbon to have 5 bonds. So then you cannot do that. And then now let us check again. If you take this bond and you put it here, now it makes this carbon to have 4 bonds, and this carbon has 4 bonds again. So that is how you can draw the structure, right? And then these are the other ways that you can represent. Again, just like the one on the alkane that we did, it is the same thing. And then now you can have a structure that looks like this. So here you have CH3, here's your CH3. You have a CH2, here's a CH2. Then you have a C bonded to an oxygen. So it's gonna be CO, and then you're gonna have what? Your CH3 over here. So again, the trick is just the same. So it's not even a trick, guys. It is just how we're supposed to do it. So you're gonna check how many carbons are connected. So it's gonna be 1, 2, 3, 4, and then now you see that that last carbon has 3 hydrogens, so it's 1, 2, 3. And then now you go to the other CH3, it's gonna be 1, 2, 3, and then you go to the second guy with the CH2. So you would want to fill in your hydrogens first. So we fill in the hydrogens, and then now you see that the last carbon over here has 2 bonds around it, and you see that it is bonded to an oxygen. And you remember that oxygen has 6 valence electrons, but then with those 6 valence electrons it can only form 2 bonds. So then you can now say you put your double bond over here very nicely, so it will give you your molecule. And then these are the other ways you can represent the molecule when they ask for your condensed structural formula. And then let us move to the next example over here. So with our next example, you have these guys. So it's your CH3, as you can see, CH3, CH2, CH2, CH2. It's just those repeating units again that you can represent just like so. And then now you see that at the end of the day here we have a C double bond OH. So now what we do here, we start with this oxygen and then we follow up with the hydroxyl group there, and then it's a C double bond OH. And then every time you see double bond OH, you need to know that this is going to be a carboxylic acid basically, guys. So now let's move on to the aldehyde. So now when we are dealing with the aldehyde over here, we are having what? We are having your CH3, can see it's CH3, you have your 2 CH2s over there, and then you know that you can still write your 2 CH2s like this. But now when we have to choose between an oxygen and a hydrogen, the hydrogen is our first preference. So you take this guy into the first preference, then now you are going to put your oxygen at the end there. So that is how you are going to do it. So even now with the types of molecules, whereby now you will be having your halogens, right? So there will be molecules where you have halogens that might look something like this. So you can have your halogens like this. So let me first draw my carbons. So you can have maybe a Br, right? So you can have a Br over here. And then when we have your Br and your hydrogens, let me just fill the hydrogens. So now they would ask you to draw the condensed structural formula. How do we do it? So we go to the first guy, CH3, CH3. And then now we go to this second carbon. As I said, we are going to take the hydrogen into consideration first. So we are going to say CH, then we say Br, and then we follow with the CH2. So it's now CH2. Then we have a what? We have a CH3 over there. So that is basically how it is going to happen. So there is another case where now, let's say you don't have a hydrogen here, but now if you don't have a hydrogen here and you have, let's say, two bromine atoms. So we have two bromine right there. So how do we do it now? What we are going to do, you are going to say that it's going to be C, and then you are going to put a bracket over there. So you're going to put a bracket, you are going to put Br, and then there's going to be 2 telling you that on this carbon atom there are 2 bromine atoms over there. So let's have another one in the other videos. So now we're going to be looking when now we are going to be having certain branches, and you're going to be dealing with other types of molecules, your alcohols, your carboxylic acids, your aldehydes. Let's go, guys. Thank you.